Welcome to the third episode of Marketing Mix Modeling Masterclass. What we're going to do today is start with testing a learning algorithm to find out if our hypotheses are true or wrong. In the last episode, what we did was diving into the exploration phase, finding that our hypothesis may be radio spend does not influence the overall sales that we make, that we generate. So in this tutorial, we're gonna see how to validate our hypothesis on the radio, and we're gonna try to predict and create a model that can predict with a certain error, a fixed error, our sales. So let's dive in, creating a new model. I'll call it simple model. And we're gonna use, I'll begin. I'm gonna use the function linear regression or linest. Linear regression works like this. We're gonna get the first line as the first member in the function. It's gonna be the output variable. Okay, gonna select everything, and then comma. The next variables, next member need to be the input variables. Then you're gonna type comma 1, which is gonna push the model to have an intercept, comma 1. So it's gonna give us all the information needed for the regression. So we're gonna see what happens after I press enter. All right, so we have a matrix of numbers. And basically what it does, the linear regression, what it does is it tries to find the linear function that best fit, that has the least error between the prediction, the y of the line, and the actual point. If we go back to the exploration phase, what the linear regression does is this. So we're gonna use linear as a type. It's gonna try to find the line that best fit the points with the least error between the y of the line and the y of the point. Super easy. And it's linear, obviously. Does not have an inflection point like this one. So the function that turns out is y equal beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 0, which is the intercept. In this case, the intercept is the last number on the right, intercept. Then we have Facebook here, then we have TV, and then we have radio. Keep in mind that when you use linear regression on Excel, the order of the input variables, it's the opposite. So, and then there is the intercept that it's always on the right of the matrix. What we have here on the first row is coefficients, coefs, which basically are B1, B2, or B3, and B0. On the third row, what we have, third row, first column, we have the R-square, which is the accuracy of the overall model. So let's color it a little bit so it's a little easier. I'm gonna color it yellow, then light yellow. Perfect. We have R-square, and then we have RMSE, which is root mean squared error, and it's the average error that we get from this model, and it is 1.75. So we average 1.75 or minus 1.75 in the overall errors that this model gets overall. So I started this video saying that I wanted to test if my hypothesis was wrong. Well, what I'm trying to figure it out is, can I create a more accurate model with radio or without radio? So I'm gonna do the same thing. I created a second model using linear regression. And I'm not going to include the radio variable as an input. So I'm going to go to raw data, I'm going to get output variable, comma, input variables, avoiding including radio, comma, 1, comma, 1. Close parenthesis, enter. Perfect. So we have TV, Facebook, intercept. I'm going to color it as always. Perfect yellow. So the R square, let's see how it is. It's 88%, 88.1%, and the past model was 88.6%. All right. The root mean square error, RMSE, is 1.76, and before was 1.759. So it's really close. What we're gonna try, what we will do now is we will try to create, we will use these coefficients in order to create a prediction. So I'm gonna do sales here over time. I'm gonna do equal raw data. I'm gonna select all sales that we have here. It's gonna be okay, perfect. Now here we have, we're gonna do predicted with spread with radio, and what I will do is this one, equal intercept with F4, so we block it, plus coefficient of Facebook ads times the input variable on the first row of Facebook ads, plus simple model coefficient on TV blocked times the input variable on TV plus radio coefficient blocked, therefore, times the input variable. Enter, we have an AT, double click, perfect. We have the prediction. Gonna set it as a number so it's easier. Okay, it's pretty accurate. Let's do a prediction without radio. No radio. Do the same thing, but with these metrics. So equal with F4 plus Facebook F4 times the input variable. Perfect, plus TV times the media coefficient, TV coefficient. Perfect, enter. All right. And we have the new prediction with the new model. I'm gonna set it as a number so it's easier. All right. So that's pretty interesting. We have two predictions compared to the actual sales. What I will try to do is I'm gonna decide which model describes better my sales and has better predictions, doing a study on errors. So I'm gonna do error radio equal as this absolute number of sales minus prediction with radio. Closed. I'm gonna block this one. Okay, what happens if I do this? All right, perfect. All right, I'm gonna, good. These are errors. No radio. All right, select everything. Set it as a number so it's easier to read. All right, let's do the averages to understand. Oh, sorry. Average. Ooh, sorry. All right, closed. 1.32. Oh, sorry. 1.35. So basically what happens is we have a little higher R square on the model with radio. We have a little lower error, mean absolute error on the model with radio. So basically our hypothesis was wrong. The model that best fit and best predict the sales and total sales is this one, is the one with including radio. Now, we covered how to do predictions and how to create really simple models with Excel. In the next episode, what we'll try to do is create an increased precision of our model, including the transformation on add stock and diminishing returns. So it's going to be a super duper technical episode, and hopefully it's going to help you make and adapt your model to have a really realistic insights. So see you in the next episode. Bye.